Hi guys, we are looking at external tangents today, but before we get to that, I'm just going to go through these two conditions first, and then I'm going to demonstrate the external tangent. So basically I'm going to do everything on this page. Let me just explain. The first condition is a line tangential to a circle at a point on its circumference. We'll start with these easy ones now, and then we will get on to the more difficult exercise, which is to place a tangent between two unequal circles, right? And this one will be called an external tangent. Okay, let's go. So I'm going to use a diameter of, let's say, 30 millimeters. No, not a diameter. Wow, a radius of 30 millimeters. So let me start here and open up my compass at 30. I'm going to use this for both circles, for the demonstration for both circles, right? So I just come somewhere around here. I think it's a good point. And I'm going to stop. I've created my circle. Ooh, I was dancing on this circle a bit too much. Alright, let me just divide it. I mean, this part here of me dividing the circle isn't really necessary, you know. But I've divided my circle nevertheless. Now what I'm doing is I'm placing P on the circumference. And I want to try and bring this back into tangent with the circle. So the first thing we're going to do, connect, okay, the center of the circle, I will call that O. I'm going to connect O to P. That's the first thing I've done. I've made a connection between O and P. Now, at this point P, I'm going to create a 90-degree there. Using P, I start P, I open my compass, and I create a semicircle, R. Yep. And these are the 2 points that have been created. Let's call that 1 and call that 2. Now simply all I need to do is bisect the distance between 1 and 2. And I'm going to do that. Stab 2, and I open my compass to what I think more than half, and I create an arc above. Then I stab 1, and I create an arc above, and we get an X. At that point where there's the X, I try to correspond that to P. And I'm going to draw this fairly heavy because this is the tangent line. Okay, that's our tangent line. And then we're going to draw the perpendicular line back to the center of the circle. And that's it. So that's our first problem completed. I'm just going to label what I've done here. Shorten this line, tangent, to the circle. For this next one, I'm going to divide the circle like I did before. Circle divided, center of the circle will be O, and I'm going to place P somewhere over here in the distance. And for this one, P is going to be away from our circumference, and I'm going to try to make back a tangent. with the circle. Alright, the first thing I'm going to do is connect a line from O to P. Once that's been achieved, I need now to find the center point between O and P. So we're going to do that by bisecting. That should be fairly easy. I'm going to stop O, open my compass to more than half, obviously less than the full distance, make an arc above, sometimes I can make an arc below. Stop P and we do the same thing, make an arc above, arc below. Correspond the two x's, x below, x above, and then we get a point in the middle. That point in the middle, I will call that point M as for the midpoint. Start point M. When we start point M, open the compass to O after stopping point M and make a semicircle which starts at M, which starts at O and finishes at P. Obviously M being the center of that semicircle. Something interesting happens. The semicircle interacts with the circle at a point, and we are going to call that point, let's call that point T. That point T, what do we do now? We connect T to P. Yep, T to P, and that's where our tangent is. So I'm just going to draw that in really heavy. Oh yeah, that's nice and solid, so we can see. And then on my other end, I'm going to connect O to T also. By doing that, we have created our 90 degree, and that is one way of proving that this whole problem is actually in tangent to the circle. So just to recap what I've done here, I've actually placed P outside of the circle and created a line tangent to a circle from a point. And obviously the point will be outside the circle. So those are those first two problems created. And then we have one more problem to tackle, and that will be external line tangent between two circles of unequal diameter. Alright, let me just write this note here. So this will be line tangent alright. Now this is where we move on to our last problem. For our last problem, we're going to be working with two circles of unequal diameters or unequal radii, whatever you want to say. The first circle is going to be radius 20, the second circle is going to be radius 40, and the distance between them is going to be 10 millimeters apart. Sorry, I said 10 millimeters, I meant 100 millimeters apart. So I've drawn the line for the 100 millimeters. I've identified where my two circles are going to start. Call one A, call one B.
What are you doing?
Shh, I'm actually recording. I'm doing a tutorial. That's what I'm doing, girls. So please do not interrupt me.
Are you a YouTuber?
Yes, I'm YouTubing something.
No, you're a YouTuber. That makes sense.
So now, like I said, our first circle is 20 radius. That's at A. Our second circle is going to be 40, and that will be at B.
You're gonna cut you out anyway.
Okay. So what do we do now with this information? We are going to take these two radii and we are going to subtract them. So we're going to subtract 20 from 40, and this is fairly easy. When you subtract 20 from 40, you're going to get about 20. So I don't have to do any working on the side or whatever. We just know we're going to get back 20, and then I'm going to stem a circle that is going to be 20 millimeters from B. And we will call that a construction circle. So I'm just going to open this about 20 millimeters, and I'm just going to draw a very light circle here. And then I'm going to call this construction circle, right? So I'm just going to pull a line across. We'll call it construction. Construction circle. Construction circle. And this, how was this created? This was created from 40 subtract 20, which is equal to 20. So this circle is 20. And this will be 20 R, 20 radius. So just placing all this information there for you guys at home who want to follow. Alright? Now, what do we do with this? We actually need to bisect the distance between circle A and circle B. I've bisected the distance, and I found my center, which is M. Then I'm going to stop M and get an arc. An arc starting at A and should finish at B. Yeah, good. So now what do we have here? We have an arc, we have two circles, two rail circles and a construction circle. The point where our arc touches our construction circle is what we are interested in. And we call that point, let's call that point K for our argument's purpose. So we connect K to A. Then when we connect K to A, we are then going to track by using a second set square. Just bring it closer for you guys at home to see. So A to K, which A on the rail circle touches K on the construction circle. So what I'm going to do is connect A to K has been connected already. So at this stage now I'm just going to track, and I'm going to track upward. Tracking, place a T square or a set square behind, and we just slide this. And we slide it to where our circle, our two circles can actually be in tangent with one line, like this. Since we've done that, we need to indicate our track lines. Our parallel lines, sorry. To show that this was tracked. So now we can actually soon start to close this. So we connect B to our tangent point, and we're going to do the same thing. Connect A to our tangent point. And wherever the tangent is, we find 90 degrees as a way of proving. So I think we have come to the end of that. Two circles, two unequal circles, and we're trying to create a line tangent between two unequal circles. Alright, so just let me end by placing a note here so that you guys can see what I've done today. And just recapping. Today we dealt with tangency. We dealt with three conditions. One, placing a line tangent to a circle at a point on its circumference, and then placing a line tangent to a circle from a point outside the circle, and then finally creating an external line between two circles of an equal diameter. And just external. But I guess it's better for us to just remember diameter rather than I think that's it. I think this is what we can say is a wrap now. Thanks for joining, and I hope to see you guys some other time.